Setting up your medium for YouTube Live.
Woohoo.
And I think that's it. If you've done it correctly, Hugo, we're now live. Setting up your medium for YouTube Live.
Fantastic. And I just heard.
I think that's it. If you've done it correctly.
Great, there we go. So if you could share the link with me, or I can go to our YouTube channel.
Sure.
Hi, everyone. Hugo and Matt here. Welcome on in. I'm just opening YouTube to get a sense for where we are and what we're doing. This is our first live stream.
It shows, Hugo, it shows.
But personality is involved as well. We had 2 watching. Now we have 3 watching, which is great because I couldn't tell whether the 2 watching were you and I.
4.
Exactly. So
look at that. It's crazy.
Beautiful. Welcome, everyone. Hugo Bown-Anderson here and Matt Rockland from Coiled. If you could introduce yourself in the chat, let us know who you are, where you're watching from.
Also gives an opportunity to learn how to use the chat. It's the first time.
Exactly. Look at that. Hi, the Kiki Tito. Kiki Tito. Great name. So I'm just going to put on social media that we're going to get a few more people over. So when you join, if you could introduce yourself. Hey, there's Scott Barnett from Ashbury Park, New Jersey. Great to see you, Scott.
So Hugo and I are going to riff here for a minute or two as people settle in. And
exactly.
Then we'll switch over to a couple of slides from Hugo, and then I'm going to play around with some Jupyter Notebook stuff. Hey, Michael. I'm also eagerly waiting for Hugo to tweet something so that I can retweet it.
Exactly. And I'm about to do that. Just creating some good old Australian morning suspense here.
Yeah,
okay.
So fun fact, it is like 7 a.m. right now for Hugo.
It definitely is, which classically I'm not a morning person, but these types of things just are so exciting. And it's somewhat different to when I first got back to Australia. I booked in a bunch of East Coast streams and webinars, and I was actually up at 3 a.m. and 4 a.m. There was one that was 1 a.m. I think the 3 a.m. was the toughest. Cool. There's Jason Baker, great, from Chattanooga, working in data science, GIS, fantastic in logistics sector. And so, as Matt said, we're going to get started soon. But in the meantime, I thought I could tell you a bit about us. We started Coiled in February. Matt started. We started the company to productize a lot of things that data scientists are finding themselves needing these days. So essentially, we're building products to help data science teams scale their data science work to larger data sets and building larger models in the Python ecosystem. And where part of the impetus for this was a package that Matt created with some other people called Dusk. So I thought, Matt, you could just give us a few words about Dusk to let people know who haven't necessarily heard of it.
Yeah, sure. So Dusk is a Python library that is designed to scale out the existing Python data science ecosystem. So if you're familiar with libraries like NumPy, Pandas, Scikit-learn, or Jupyter, Dusk very much comes out of those library communities and helps them work on many cores in one machine or across many machines in a cluster. So that's Dusk. It's just sort of an extension of the tools you already know and love, but now operating at scale. It is an open source package maintained by a bunch of amazing developers and community members that are sort of really embedded with the Python space.
I just noticed Richard Jones has joined, and then Daniel Chen as well, who is a friend of ours in the Python ecosystem, and we've worked with time and time again. So hey, Daniel, and hey, Richard, great to see you both. Thanks for that intro to Dusk, Matt. I'll also add, I think, the first thing you want to do, and this is something Dusk does wonderfully, is scale up to do out-of-core computation on a single workstation. So you can scale up to work with larger data sets before moving to a cluster or to the cloud. But then you can also scale out onto the cloud as you want to scale even more. And so we're going to see a bit of that today. Hey, and Ray Bell just joined, said
Ray.
hi, Coiled. That's fantastic. That's cool. We got over 30 people watching. I wonder whether
I think we should.
my parents said they'd join, and I think they probably are there sneakily. It's the first live stream, friends and family as well, and it's 7 a.m. for them. So hi, mum and dad. Great to see you here. So we've got 1 minute to go until we're actually gonna start jumping into the material. But what I'd like to do to start, Matt gave a really nice introduction to Dusk. I'd just like to talk about several actual use cases. I'm going to bring up some slides for that and talk you through those. And you can actually see one of the wonderful researchers who uses Dusk actually has created an amazing cellular image that you can see behind me, which we refer to as the Stingray cell. And we'll see some more of Tally's work. Hey, and there's Owen Lamont, who's calling in from Perth, Western Australia. Owen, what time is it in Perth?
There is also, beware, there's like a 20 or 30-second lag in between us saying something and other folks hearing it. So you shouldn't wait for Owen on that response.
Exactly. And I think it's 3 hours earlier than it is in Sydney anyway. So that's pretty wild. Okay, great. So Owen just said 5 a.m. exactly. Okay, so that makes it 7 a.m. here. And so what I'm going to do is I'm going to share my screen and just say a few words about the use cases of Dusk. So let me go here. Just bear with me. Matt, could you let me know if you can see my screen?
I can see your screen just fine.
What does it look like?
It looks like a browser with a slide deck attached to it.
Fantastic. That says who
Slack in the background. So beware.
Yes, but I don't have Slack notifications popping across. And I've definitely been burnt myself by that before. Fantastic. I do not want to share that. I want to present. Great. So let's just have a quick look at these slides around who uses Dusk. There are many use cases we can talk about, but it is used wherever Python is used, and it does really form a foundational part of the PyData stack for scaling your data science work. We're just going to see a few examples from life sciences like HMS, Chan Zuckerberg, Novartis, retail, finance, and geophysical sciences. And we won't go into too much detail here because in future Science Thursdays, although it is Science Friday for me, we're calling this series Science Thursdays because it's Thursdays for most people currently. I wonder if that's true. But we're going to dive into more of these with the experts in future Science Thursdays. So I just wanted to show you some great examples from high resolution cellular imaging. And as we see, Tally, who created this image and the image in my background, has said explicitly that Dusk lets him prototype pipelines on his laptop and scale them easily to his institution's computation cluster. And the fact that it mimics common APIs, such as Pandas, as we're gonna see today, makes adopting it nearly effortless. Okay. Similarly, we see these incredible videos which have used similar techniques, and then we have people at Novartis, all over Novartis, using Dusk as well. In particular, Eric Ma, who I'm going to have on one of these sessions in the very near future, and he does a lot of work on machine learning and uses Dusk for that purpose. Some really exciting use cases in retail. Walmart is a very interesting example of using Dusk for distributed machine learning and demand forecasting. And you may have seen recently, particularly during these COVID times, that demand forecasting has changed a huge amount and changes on a weekly basis for Walmart. So it's very exciting to know that Dusk is used in the machine learning pipelines at such a critical time. Similarly, JDA Blue Yonder, retail logistics. And then another really exciting example is word embeddings at Grubhub. Okay, so this is, I haven't shown you any natural language processing yet. We've seen imaging and machine learning, but this is for natural language processing and using it for pre-processing and ETL alongside TensorFlow. Now, very good use case at Capital One with respect to ETL and machine learning pipelines. I'm not going to dive into this too deeply, but what I want to tell you is that Dusk is used at many different touch points along the ML pipeline here. And this is something that we're going to go a lot deeper into in the near future on these sessions. And this is Dusk paired with XGBoost and Rapids as well. So we'll see a lot more of that. Then I just wanted to say a few words about the geophysical sciences. We have Shell Genteman from the Farallon Institute, who's part of the Pangeo collective as well. And I actually spoke with Shell very recently, and we're hoping to do one of these sessions as well soon. But the point is that oceanographers, as it says here, produce huge, massive simulated data sets of the petabyte scale. And they can't even look at the results before Dusk. So that speaks to actually, there's a challenge that arises when you have these huge data sets of being able to work iteratively and on the fly. And the way Dusk interacts with the Jupyter ecosystem allows you to do this from the comfort of your Jupyter notebooks. As you'll see, something we're working on is scaling this up to the cloud to make the experience of bursting to clusters as seamless as possible as you work with Dusk and Jupyter and scikit-learn. Los Alamos National Labs has some very interesting use cases, and the UK Meteorology Office. And I'm going to ask Matt this because I'll probably get it wrong. But did Jacob Tomlinson, who you worked with at NVIDIA and now is core on Dusk, start off at Meteorology Office, or did I make many of those facts up?
Yeah, that's right. Jacob, who's also giving a tutorial. We should plug his tutorial tomorrow.
Yeah.
I'm actually here tomorrow too with Jake. Yeah, started the mid-office. Mid-office has been a great contributor to Dask. Really early users, early adopters. It's now used in lots of different places inside of the organization. But yeah, we then stole him over to NVIDIA when I was working there, which I regret because I can't now also steal him over to Coiled.
I wonder if I can. So I think Jacob, I also want to say hi and give a shout out to Jacob. He was very helpful in thinking about tech with setting up this YouTube live stream. And that speaks to a greater point that I just want to make very clear, is how so much of the work we do and the work that Python API and software consumers use is built on the work of an entire community of people. And I'm really looking forward to bringing you so many of those stories and voices from the community at large in the coming weeks, months, and years. So without further ado, I thought I could stop sharing my screen. Matt could start sharing his,
Sure.
and we could jump in and just have a look at some Pandas code, see how that generalizes to Dask code for out of core computing to scale it somewhat, and then maybe we'll even have time to jump in and see a bit of Coiled Cloud and what we're building. Would be very exciting.
Tiny bits. Yeah. Okay.
So I'm just looking. So one sec, I just want to give a shout. We've got Dimitri. Hey, Dimitri from Moscow, Russia. Ray Bell says, never going to get bored of hearing Hugo say Dask. That's actually a really good point. It took me a couple of years of working in data science before starting to say data science. So I wonder when I'm going to switch back. And we have Michael Sterling asking, is the cloud tooling project a proprietary Coiled product or a Dask product? I'm happy either way, or just curious. It's Michael, great question. And it's a product we're building at Coiled. And part of the rationale there is that we're building tools and products for teams that meet the needs, not only of IC data scientists, also team leads in terms of them having access to advanced telemetry over cost and usage and distribution of resources across the org, and IT as well. So in terms of auth and security, among other things, I think part of the point that I'm making there is that these are gaps that OSS and in general, and Dask in particular, doesn't necessarily solve, nor should they. And that's kind of the raison d'etre for companies such as Coiled arising to meet the needs of teams and organizations as open source software is adopted more and more by organizations at large. enough from me though. Let's jump in and check out what do we have here, Matt?
One of the things I'm really looking forward to with working with you, Hugo, is that we both have large personalities. I think we're gonna like struggle against each other. It's gonna be fun. I'm looking
Yeah,
very much
absolutely.
so yeah, I've got tons of thoughts on open source and proprietary and how to mix them and how to make sustainable open source companies. Probably a topic for a different webinar. Right now, I'm gonna jump into some code if that's okay. I am hoping
Yes.
this resolution is visible. If folks are concerned about that, let me know. But this seems okay. So yeah, I want to play some code. And what we're going to play with is a very normal, boring workflow with pandas. We're going to look at an old, boring data set, the New York City tax cab data set. But we're going to take that workflow and we're going to scale it from pandas on a small sample of data to pandas on a larger piece of data to using Dask on my laptop. And then from that up to the cloud. We're going to use the Coiled product, but you could use this with any open source product as well too. So I really want to focus on that
And so
transition.
Just to clarify, you're in a Jupyter notebook in Jupyter Lab as well currently, which is where a lot of data scientists do their work these days.
Yeah, it's where I personally do my work. I like Jupyter Lab. It has, one of the reasons I like it, it has great Dask integration now because of the fine Jupyter Lab folks. So yeah, I've got the CSV file, and this is the New York City taxi cab data set. I have previously downloaded a bunch of it from S3 onto my laptop. So it's sitting on my laptop. I'll open up a little terminal here, and we can go and we can look at, I think it's in data NYC Taxi. Right, so I've downloaded a bunch of files. They're sitting on my machine. And I can read a little sample of it, just downloading, I'm reading in 10,000 rows into pandas. And I can go in, I can look at various pieces of data here. I can do df.passenger count. I'm assuming that a lot of the people on this call are probably pretty familiar with this API. So the workload I want to go through is a data engineering workload where I want to take this same data set, process it in various ways, make it a little bit cleaner, store it in a nice format. We're going to use Parquet rather than CSV so that our teammates can then read it more efficiently. Then we'll repeat that same relatively simple workload 3 different times at different scales. So one of the things I like to do—
Can you just tell us a bit more about Parquet for those who haven't necessarily heard of it?
Yeah, we'll get into that in a moment.
Okay, great.
So the file format CSV here is human readable, right? We can all go look at a little bit of this data set. And a little bit of this data set, and it's text that we can read as humans. Turns out computers and humans are a little bit different. So we want to just change the format a bit. Parquet is a great data file format. It's maybe becoming the standard today for a lot of this tabular data sets. And we'll see why it's nice in terms of reading and writing speed. But before we promote to Parquet, we want to make it a little bit cleaner. So the data set as it's come to us, Pandas has given us some data types that are sensible, but not necessarily ideal. For example, these columns here, which appear to be dates, Pandas is storing as Python objects or probably strings. We can probably make that more efficient. Some of these data types, like int64 for this vendor ID, probably don't need to be 64 bits long. They can probably be 8 bits long. And so what's really common is that as we're sort of ingesting this raw data, we put it into some more analysis-ready format like Parquet. And in that process, we're going to clean things up a bit on the way. So I've done a little bit of that work already down here. So I'm going to use the pandas parse dates keyword argument to give us date times rather than strings for the datetime columns. I've also looked at some of these columns like vendor ID, passenger count, and I'm changing their type rather than from a 64-bit integer, so it could be many billions of values, to an 8-bit integer, so only 0 to 255. There are some other things that I cleaned up in here, just make things a little bit nicer. I might also make some new columns. It's quite common that our data scientists will want not just the raw data, they might care about something else. So for example, in this data set, we have information about the fare and the tip. Maybe we're making a machine learning model on how well people tip. And so we might make some new column. Is it a fair amount? Actually, there's a.
And I'll also just note that this is a very common and an important way to work in the sense that Matt's working on a subset of data, doing something locally, doing some exploration, maybe doing some feature engineering in order to then do this at scale. And you see different challenges emerge at each point as you scale up and then scale out. But it is very important to note that traditionally you'll subsample and experiment locally before doing anything at scale, right, Matt?
Yeah, and we can see that here. So I'm going to scroll up a little bit. When we first started this, I read just 10,000 rows to get a sense of the data. And that happened in milliseconds. Now, when I'm ready to do a bit more work, I actually read the entire data set. And that took 28 milliseconds. Right? So reading CSV files takes a little bit of time. That's OK. I can wait 28 milliseconds. That's within my tolerance of writing code. I can then operate on that, and that happens relatively quickly. And now, I would probably, again, here, I would do a lot more work. We're not going to do any more work here. This is going to sort of simulate what we would do normally in the feature engineering process. Now I might save that to Parquet, right? And so again, reading this from CSV took 28 seconds. We're now writing that to Parquet, took 6 seconds to write. And the nice bit of that is that now if our teammates want to read that same data set, so now rather than using the CSV function, we're going to use the Parquet function. We grab the same file name. So I can now read the entire data set in not 28 seconds, but 2 seconds. And what's quite nice is that if I get just out, one column, like say the passenger count column, that can happen quite quickly. So that happened in 7 milliseconds, right? And so what's really nice here is that we have this big data set, or modestly big data set, and I can operate it from disk in kind of the same way I would operate it on it from memory. It's about as fast. I'm kind of cheating here, right? This column is actually stored now as an 8-bit integer. And so that entire column fits in a very small space. So that's why we like Parquet. It makes it way more efficient for future downstream analyses. So we now want to scale this up, and that's where Dask is going to come in. So the first thing we want is, if we go back to this line here, we read in only the data for January. And that took about 28 milliseconds. What if we wanted to process our entire data set? So in principle, with Python, with pandas, we might do a for loop, right, for file name in glob, put our file name in there, but not rather than 0, 1, put a little star. And we might read in a data file, pandas.readcsv. We would then copy all that stuff, and we would call to Parquet.
And I'll just add there that when writing and reading code and seeing people code like this, keep in mind what is potentially parallelizable and what isn't. If you have multiple cores on your local workstation, if you see a for loop like this, I'd love you to be thinking, hey, this is something which I could probably parallelize depending on how long each iteration of the loop takes.
Great point, Hugo. Hey, Hugo, do you have any great way to parallelize for loopy kind of Python code?
I think Dusk is probably the go-to solution in the PyData ecosystem.
Oh gosh, I think you might be right. Yeah. So so I've just made a bunch of processes in my local machine with Dusk, and I've clicked this little button over here to tell Jupyter Lab to look for my local Dask worker, and they've hooked up here. So I've got
okay. I'm going to stop there for a second. A whole bunch of stuff has just started happening. Yeah. So I'd love for you to talk us through so what Dask.distributed local cluster client does, and then what this wonderful dashboarding is on the right.
Yeah, let me. Yeah, that's a good point. So we did a few things. We imported some libraries for some classes from the Dask distributed module. The first one we created was a local cluster. So this is a Dask object which creates a bunch of resources on our local machine. So in this case, it spun up 4 processes on my laptop, which have 3 threads each. And so we're going to use those 4 processes, those 3 threads each, 12 cores in total, to do our work for the next session. Now, local cluster is something we could swap out for something like a Kubernetes cluster, or a Yarn cluster, or a Slurm cluster, or an SSH cluster. There's a lot of different ways of setting up Dask, but the simplest one, just for local development, is local cluster, and it carves up your machine in nice ways. We will also, in a moment, we'll see coiled cluster. That'll be sort of the last few minutes of this whole session. Then I connected my Dask client to that cluster. So, my notebook can connect to lots of different clusters at the same time. Said, hey, I want to use this local machine, please. Now, the Dask cluster serves a dashboard with a bunch of different plots that show you what's going on. And we can access those plots here. They're accessible from JupyterLab. So if I wanted to get, the bandwidth on a per worker basis, there's a plot for that. Right? We haven't done any work yet, so there's no actual bandwidth yet. But there's also plots. And then JupyterLab is letting us sort of lay all those out on our screen. So we can give a nice little workspace here. And this will sort of start spinning up in nice ways in a moment. Maybe a good way to show that is there's this cluster map, which is showing us the state of our cluster. So there's one scheduler in the middle, and that's this purple bit, and there's 4 workers. It turns out that actually in this, usually I would use this default, but because I'm also screen sharing and streaming out to YouTube and my machine is running Linux, which doesn't have great GPU support, I'm actually going to sacrifice one of my workers. So I'm going to go from 4 to 3. And so I made that change in my notebook, and we could see that change be reflected on the right.
That's really cool.
Yeah, it just gives me a sense for what's going on. And that's actually really important,
Yep.
that sense for what's going on. We find that the dashboard really helps with people to understand performance and when things break down. So that's my session. And I've got this whole set up just the way I like it. This is the way I like to work with Dask all the time. So we're going to take this code that we had from before, this pandas code, and we're going to alter it a bit to work with Dask. So rather than pandas, we're going to use Dask DataFrame. So rather than PD for pandas, we tend to use DD for Dask. Rather than just this one file, I want to look at all of the files. So Dask, so that took 33 milliseconds. Dask didn't read the data in that much time. It's just looking at sort of the first few hundred kilobytes of that first file to get a sense for the data set. And it's giving us the sort of lazy thing that we can play with in the future. So we see the structure, all the sort of.
And I'll also.
Yeah, go ahead, Hugo.
Oh yeah, I was going to say, I'll also add that, as Matt alluded to, the code you write is very similar to the pandas code, and it runs pandas in the backend. And this actually speaks to something Matt wrote about recently, that there were technical goals of building Dusk, but one social goal was to invent nothing, to make it as easy as possible. People use NumPy, Pandas, and other packages to scale their work using Dusk, which I'm really excited by. I'll also ask you, we've just got a question from Daniel Chen saying, for later at some point, not today necessarily, is it possible to show Dask using a user-defined function on a string column? Most, if not all of the examples he sees are always on numerics.
Yeah, sure. I mean, it's the same. I'm going to sort of keep going from my current track. Yep. Yeah, it's the same as what you do in pandas. You might sort of care a little bit about how, maybe you want sort of more processes and less threads because you're dealing with strings. But generally speaking, it's the same. But yeah, I think that would be a great example for a future follow-on. Maybe we can get one of the pandas devs to come on and sort of show a lot of the pandas Dask integration.
That'd be really cool.
I'm going to charge on. So yeah, same code as Hugo was saying before. So it's the same stuff as pandas. And then we're going to change this 0, 1, just the full year. Now we're going to run. So hypothetically, everything's going to work. Actually, it's not going to work. We're going to run into a bug. But seeing what that bug is going to teach us something. So Dask has split those 12 CSV files into 127 little chunks. Those 3 workers are all chomping away at that data. We're reading stuff, we're writing stuff, we're reading stuff, we're writing stuff. And I'm expecting
in the cluster map, are the ones that are expanding, is it a literal visualization of which ones are working at what time?
Yeah, it's what they're working on. So the colors, these green colors, reading CSV, that corresponds to the thing that you're seeing over here. So when this little guy turns green, he's reading a CSV file.
Beautiful.
If it's a light green, he's writing some data. This black square up here is an error, right? So Dask is telling us that something broke here. What went on? So it worked for a while. We processed a lot of our data set, but we couldn't process all of it. Something happened. And so we get this long error message. And this is something that actually you need a little bit of pandas understanding to fully interpret. So I'm going to walk you through this. This is a super common error message. And we're going to sort of see what that means and why we ran into it. So Dask is saying there are mismatched data types. We expected these columns to be integer data types. So like the passenger count column, we expect it to be an integer. But actually what we found when we parsed some file way deep in, right, this black square wasn't the first one. It was sort of, maybe it's data for March or for April. We found there was actually a float 64. And so Dask is telling you, hey, look, you can copy and paste this code into your read CSV file, your read CSV command, and things will be fixed. Or you can apply the assume missing equals true command. So one might ask the question, wait a minute, why are there floating point passengers? Why are there fractional passengers in a cab? What happened here? So what Dask does is it reads the first bit of your data to get a sense for your data types. It looked at that passenger count, it saw a bunch of integers, it said, great, this is an integer column. Now again, in April or in May or somewhere deeper in the data set, that wasn't the case. It's not floating point though, it's missing. So pandas by default has been a big pain point for a long time. Pandas did not have support for missing values in integer columns. It always represented them as floats using the NaN or not a number value. And so that's again, a tricky little bit. You need to understand pandas to understand that error well. But fortunately, Dask tells us exactly how to resolve that problem. Whenever you see a really informative error message like this, it's because a bunch of people run into the same issue. So now we go ahead, we run that again. And what's interesting here, what's nice is that we couldn't have run into this problem by looking just at a sample, right? Oftentimes, when we are looking at that little sample, that first bit of data set, we learn some things and we iterate really, really quickly. We solve a lot of problems. And then once we've sort of done that work, once we sort of have exhausted everything we can find at a small scale, we increase our scale and we run into new problems. And hopefully our tools can tell us about those new problems. In this case, there was a little bit of data that was off. What happened here? Cannot convert non-finite values like an NaN to integer. This is because our as type, afterwards we're converting these back to integers and that isn't doable. It turns out that Pandas has actually recently implemented missing value support for their integer data types. And you can specify that with capitalized types. So this is what Hugo was saying earlier. The fact that Dask didn't reinvent pandas, the fact that we're just using pandas, means that like when pandas adds support for missing values, Dask DataFrame gets it too. So that's it. I think everything will work fine.
To that point, we've had a few comments around some preferences for Dask over Spark, and I don't want to wade into this too much because both have strengths and both have weaknesses. But someone pointed out that they prefer solving Python error messages than JVM errors, which can happen in Spark, for example.
Sure, yeah. That's definitely one reason why people like Dask. It's not just the trace backs, but it is Python native. So it's very, it's like the way you're used to working, maybe with pandas or with other tools. So this is going to work. This is going to work just fine. It's also going to take a little while, so I'm going to stop and move on. But this is nice, right? We're able to use our complete machine. We're able to scale up to larger data sets, and we're able to hit bugs and move past those bugs with the knowledge that we already have, the knowledge of pandas. So I'm going to stop this and move on. We're now just going to scale it to the cloud. So at the very start of this notebook, we actually started by downloading a bunch of data. Right, I ran this wget command actually before people got here because this takes a while. My internet connection isn't that fast, and it sort of takes an hour to download everything. But oftentimes, what we see is we see data scientists downloading data, operating on it locally, and then pushing it back up to some other source. It would be nice if we could just operate on the data on the cloud on S3. So that's what we're going to do now. So we can go look at this data on S3. So I'm going to use the library S3FS. S3 file system.
And so what is S3FS?
Yeah, so that's a great question. S3FS is a Python library that gives you a file-like interface on top of the Amazon S3 file system. These are maintained by the Dask community. So for systems like S3, for Google Cloud Storage, for Azure Data Lake, I think actually Ray Bell, who is in the chat, is one of the Azure Data Lake file system maintainers. So that's community for you.
Thanks for your work, Ray. G'day.
Yeah, thanks, Ray. These are mostly maintained by an old-time Dask maintainer called Martin Durant. But it's a nice API. It looks like a Python file system API. I think now like the Pandas library uses these tools, even though they're originally developed by the Dask team. So we can go and look at, I think this is all in the bucket of the New York City Taxi and Livery Commission maintains. I love the term Taxi and Livery Commission. It sounds so classy. And I think this is all in the trip data folder. Yeah, so here is all of the data that the New York City cab system maintains. There's a bunch of it. We are just looking at these files down here. But if we wanted to, we could, open up one of these files. Let's go ahead and do that. Yeah, so when we say that Dask is PyData native, what we really mean is that it uses PyData tools, but also contributes back to that same ecosystem. And so we really care about making these things feel really natural. Whoops, I did not want to do a full read because that's going to take megabytes, but maybe we can read just 1,000 bytes. So for example, this mimics the Python file interface. So if you're familiar with Python, the file interface, our interface S3 looks just like that. And so we've also worked with all the different libraries to make sure they can also consume these things. So it's a nice little tidbit. But we're now going to use our Dask data frames, but operate on a cluster to read that data from S3 directly into data that's to machines that are in on AWS, and then operate on it from there. So I'm going to ask for a bunch of machines on AWS. That's going to take me about a minute.
And you've set up an account already.
Yeah, I have. So let me unpack a few things that just happened. So first, we are now switching from open source land to proprietary land. So I'm putting on my for-profit hat. Hope you all don't mind. You can do all of this with other tools. It'll just take you a while. Maybe at the end, we can talk about how one might have done this with standing up Kubernetes by yourself, setting up security by yourself, et cetera. But
I'd just like to make clear there, that's the other way to do it has a variety of pain points that essentially are what we're working to solve, among other things, at Coiled.
Yeah, but for now, let's just pretend that we've solved the deployment problem, which we happen to solve with Coiled. So yeah, what did I do here? Here I authenticated with some service. Here I'm using Coiled, you could use something else. So I've logged in, it's got credentials locally, and it's using those credentials to spin up a bunch of machines on AWS. I'm asking for 10 machines. Each of those machines have 4 cores and 16 gigabytes of RAM. I also had to specify the software I wanted those machines to have. And I specified that software by asking Coiled to make for me a software environment. So I'm skipping over a bunch of things here that I think we should go into in a future session.
Yep.
I just want to sort of imagine all of that works for you. Imagine someone else has set that up for you. How can we play with it? How can we go forward? How can we scale up our analyses? But yeah, I'm definitely skipping over some stuff.
And the other thing I just want to state, I'm very excited that you're working on AWS from the comfort of a local Jupyter lab and Jupyter notebook session.
Yeah, definitely. I'll emphasize that more in a moment. Yeah, so here's more or less the same code we had before. A couple of things have changed. Rather than looking at my local file system, I'm looking at S3 using the S3FS library under the hood. All the rest of the stuff is the same. I had to pass a couple of extra options to S3FS itself, which were a little bit tricky. We'll talk about some failings in a moment. Got the same code we had before. Oh, and then now, so I have this cluster, right? So now rather than this sort of local cluster I was working with right now, let's switch. Great. So now, rather than 3 machines with 4 cores each, I've got 10 machines with 4 cores each. You can see them here. Right. And I've got, in the same session, I'm making my Dask data frame, I'm doing the same operations. I'm now calling toParquet. And so my local Jupyter notebook is now telling those 10 machines on the cloud to read chunks of those CSV files that are on S3, to process them in the way we've talked about, and then to write them back out to my own bucket. Right? So I want to share this with my colleagues. And so I'm going to take that public data set, massage a little bit, store it in my private bucket so my colleagues can then play with it. That took, looks like maybe about 30 seconds or so. No, right on the nose. Rather than me having to sort of stop it midstream because it was taking too long. So we got a few benefits here. We got to scale out to larger machines, and that's nice. We also didn't have to download and re-upload the data. We got to operate on the data where it lived. And then Hugo, to your earlier point, what I really like about this whole system, the thing that is rare to see, is that at the bottom of this notebook, we're operating on the cloud. And at the top of this notebook, we're operating with a 10,000 line sample of data with pandas, all on my personal machine where everything's set up the way I like it. So this transition from like a local user workflow to Dask in the middle here, working on, using a lot of cores on one machine, off to running on the cloud, is a transition that I personally want for my data tools. I don't want to have to sort of switch into running things on Databricks, switching, my libraries, switching everything else, switching where I run things. Everything that I want that's sort of user-focused, that's human-focused, is on my laptop, but all the computation and all the storage is on the cloud. And that's really, I think, the user experience that we're really passionate about at Coiled, is making the scalable data science experience as ergonomic as possible. And to me, this is what fits. I'd actually be curious to know if it also fits other folks. So yeah, Hugo, any thoughts, any questions?
So I had one statement, which is, if this resonates with you, please do get in touch at product@coiled.io. And if it doesn't, do as well, because we're very interested to hear what type of pain points you're working through. And we'd love to be involved to have conversations like that. You can also sign up for our closed beta on our website on coiled.io. We have a question from Jason Baker. Jason asks, is there any idea if there's a similar wrapper functionality for the S3 buckets for GCP buckets? He also states he loves the interoperability. So thanks for that. Thanks for that, Jason.
Yeah, so you should look at the library GCSFS, which does the exact same thing. It fits the exact same interface. And if you're using Dask, you can swap out the S3 for GCS. Yeah, I mean, if you look at the Dask docs, I think there's things for HTTP servers, there's a Dropbox thing, there's a Google Drive thing, there's Azure, there's HDFS if you're on a legacy Hadoop system. There's all sorts of connections. Yeah, Dask has been around for a while. Like, these things have been contributed by dozens of people.
Thanks, Matt. So I think I'll say some final words, but what I'd also like to say is that if you check out our website and you enjoyed this, please add your email address to our email list. And what we're going to do is we're going to put this video live in the next few days. And if you enjoyed it, definitely share it with your colleagues and friends and other people you think would enjoy it. We're going to be doing this in the foreseeable future, hopefully every Thursday. So I'd love to thank you all for joining us for our first Science Thursday. And as I said, check out our website, follow us on social media, share this once it's live, and join us for our closed beta and reach out about product if you'd like to. Perhaps, Matt, was there anything else? Anything I've missed there?
No, that's it. I'm just playing around. It's a fun data set. I'm actually sort of curious to go look at not just 2019, but the entire system. But no, that was great. Thanks, Hugo.
Great. All right. Thanks,
everyone.
everyone. And we'll see. Oh, yeah. And next week, actually, we're going to be doing Science Thursday with Chris White from Prefect. And they use Dask in their product, right?
That's right. Also add one more thing. So if you all are interested, go to dask.org/survey. And we'd love to know what you think about Dask, what you would like, how you would like Dask to change, what's important to you. This could be useful for you. Sorry, my open source hat back on, by the way. This is not a Coiled thing. Yeah, let us know what's important to you. If you use Dask, great. If you don't use Dask, still let us know what's important to you. We'd love to hear what your pain points are, what works, what doesn't work. Let us know.
Fantastic. All right. Thank you, Matt, very much. And thank you, everyone, for joining our first Science Thursday.
Cheers.